Okay, Assalamualaikum and good afternoon, everyone. So, my name is Zamri. I guess some of you already know about me because I can see some of them here is my ex-student. Okay, you can just call me Zamri. Okay, I work as HDC as a senior technical specialist. Okay, and my department is Malaysian Smart Factory 4.0 and also E&E department lah. Okay, this is some rest of my background. So I got around 9 years of experience in training and development with HDC, and my expertise in more or less is my focus is more on mechatronic system design. Okay, and lately I just gone through for ni lah, IoT or Industry 4.0 technology. Okay. Okay, so you can see here. So Malaysia Smart Factory 4.0 actually is a orang kata apa, digital twin from Swiss Smart Factory lah. So actually we are more or less is adik-beradik lah. Okay. So in 2013, I go HRDC sent me to Germany to learn some module regarding the apa Master in Mechatronic in Icon Institute at Aachen, German. And 2018, I go to Switzerland to learn something regarding Industry 4.0 with Swiss Smart Factory lah. So I come back in Malaysia in 2018 also. Then we started to develop this Malaysian Smart Factory 4.0 at HRDC. Okay. So today I'm gonna talk about digital manufacturing, and digital manufacturing is part of Industrial 4.0 technology lah. So I will start with Industrial Revolution history. I will talk about the story of IR 4.0 first. Then after that, I will go through to digital manufacturing lah. Okay. So actually, Industrial Revolution started in 790. Okay, this is the first revolution. So during that time, industry started using mechanization lah. So they're using wind turbine, water flow, and they also use animal to move their mechanical machine lah. Okay, their machinery. Okay, but the most famous achievement during that day is the steam engine lah. So during that time, they're famous with steam engine. So we got a train with steam engine. So we got a car with steam engine. Okay, and we also got some factory with the steam engine lah. Okay, this is the first industrial revolution. Then in 1870, so this is the second industrial revolution lah. So during that time, electricity has been introduced to the factory. Okay, so factory started using electrical motor, analog device. Okay, during this time lah. So during this time also, we got some famous scientists lah, such as Nikola Tesla, Thomas Edison. Okay, they all is in this era. Okay, so in the third revolution, third industrial revolution in 1990. So actually this is the end of 20th century. Okay, so the industry started to use electronic device. So such as PLC, computer, and some control device. So they embedded this control device to their machine. Okay, so their machine can run automatically without human lah. Okay, so either partially automated or fully automated. Okay, as you can see from the revolution, the first revolution until the fourth revolution, okay, there are less what we call less human work, okay, at the factory. Okay, they start a lot of people here. So they start introduce division of labor. So a lot of people work as operator in industry to assemble something, right? So in third revolution, there is less people in the manufacturing line because they already replaced the human with the robotic. Okay, how about the fourth industrial? Okay, this is the main concern of the people worldwide, so because they think technology will replace human in working area lah. Okay, this is more or less is true. Okay, unfortunately, I said that this is true. Robot will replace human. Okay, but that's why HRDC came out. Okay, not only HRDC, a lot of training center also came out with this Industry 4.0 technology punya courses lah, supaya so that we will still have job in future. Okay, we can secure our job. Okay, because in future, unskilled worker will have less job later on. Okay, so later on, only people or human or worker with some skill, okay, certain skill only can survive in this new era. Okay, so this is the fourth revolution, industrial revolution. So we call it cyber physical system lah. So in this IR 4.0, we will introduce cyber physical system. Later on, we will look what is this cyber physical system. Okay. Okay, so in fourth revolution, actually they already have some industry without human. Okay, so their worker only come maybe one day at month, okay, 2 day a month, just to come to check and do some maintenance and so on lah. So okay, actually the less unskilled worker like operator, everything already replaced by robot. That's why we need to improve our skill started from today lah. Okay, okay. All right. So this is the history of Industry 4.0. Okay. It all started in 2011 in Germany. Actually, their government, okay, the federal government, has income this high-tech strategy 2020. Actually, this more or less is similar like our wawasan 2020 lah. Okay, right now they already replaced with, not sure what is, tak tahulah apa lagi kan kat Malaysia ni. Okay, actually this is the wawasan 2020 for Germany lah. They come with high-tech strategy 2020. Okay, this is in 2011. Then in 2013, at Hanover Fair, this is the technology fair. This is very big technology fair in the world. Okay, Germany officially introduced this Industry 4.0 technology lah. Okay, and later on after a few years, okay, more country already go through this Industry 4.0 technology lah. Okay, they started to develop this platform Industry 4.0. Okay, they started to computerize their manufacturing, or we call digitalization lah. That means they start collect data for everything in manufacturing area, not only about the machine data. So right now we have product data, process data, human data, and so on. So there's a lot of data in manufacturing. That's why we will see this. Okay. Then after certain years, maybe around 2017, if I'm not mistaken, okay, the application of Industry 4.0 is gone. This technology 4.0 area is gone beyond manufacturing. Okay, not only in manufacturing area, but right now they come to our household. They come to our a lot of things lah. Okay, right now not only industry got ni, so this technology come to our household, such as right now we got smart bulb, smart light, so we got a smart watch. Okay, so everything actually that was is originally come from this platform Industry 4.0 lah. Okay. Okay, now in future, not in future lah. Right now, so there are convergency. So they merge together the OT and the IT, operational technology and information technology. Okay, what is OT? What is IT? Okay, as a brief, operational technology is how we collect data from our machine. Okay, so we need some sort of device like smart sensor and gateway, IoT gateway. So we can collect data from anything. Okay, like your phone, your light, your watch, okay, anything. Okay, anything can transfer data to cloud lah. Okay, then after we transfer the data, that come the information technology. So the information technology part, they will utilize whatever data we give to them lah. Okay, actually the information technology is more to data analytic, okay, AI and others lah. Okay, so our part or my part is more focusing on operational technology, how to transfer the data to the cloud. Okay. Okay. So when we talk about Industry 4.0 technology, it's best to describe it using this 9 pillar of Industry 4.0. Okay. If you Google, you will see this 9 pillar lah. In Malaysia also they're using this 9 pillar to describe Industry 4.0 technology. Okay, this 9 pillar is cloud computing, big data analytic, Internet of Things, advanced robotic, cyber security, simulation, AR, additive manufacturing, and system integration. Okay, so we will go through one by one of this pillar. Later on we go for digital manufacturing. Okay, first pillar is Internet of Things. Okay, before this, only human can use internet through computer and mobile phone. So we can Google, so we can use our ways, so we can use anything related to internet through our phone, okay, or our laptop or computer lah. Okay, before this, okay, but right now, okay, we can connect almost everything to internet. So we need a sensor and actuator. Okay, sensor and actuator. Sensor is input and actuator is the output. Okay, and we can connect it to gateway to send the data to the cloud lah. So by using these two devices, we can connect almost anything to cloud. Okay, cloud device or cloud service lah. Okay, for example, we have smartwatch. Okay, smartwatch. Before this, our watch is only used to tengok masa lah. Okay, so right now we know 2 p.m., 3 p.m. Okay, that's previously. Okay, right now our watch can sense our blood pressure. Okay, then they can sense our step. Okay, so how they will sense? Because the watch have the sensor inside it. Okay, okay. Then we can use a certain gateway. Okay, maybe in watch they use a different gateway, but in industry this is the gateway lah. Okay, they are came up with a lot of brands and many form lah. Okay, there's some is small and some is bigger, depends on their capability. Okay, depend on their voltage and so on lah. Okay, so generally by using these two component, so you can connect almost everything to internet lah. Okay, usually every device came when you buy is came up with they come up with some software lah. If you buy the smartwatch, normally you can download the apps or software to your phone to see the data. Okay, because if just like this, you cannot see what is the device doing during that time. Okay, so using this software, you can do some sort of visualization lah. Okay, so right now you can see your step, your blood pressure and so on using this visualization. Okay, right, this is Internet of Things. Okay, next is Big Data Analytic. Okay, this is one of the 9 pillars in Industry 4.0. So usually there's a lot of agreement in internet if you Google about this Big Data Analytic. Some is 9V, 8V, 7V. Okay, so generally this is the 4 important V's that you need to know if you involve with the Big Data Analytic lah. First is volume. Okay, volume is talk about how big is your data. Is it 10 data is considered is big data, or maybe 1 million, 1 terabyte. Okay, so this is you need to taken care. So the volume, amount of data. Then is variety, because when a lot of things connect to internet, they come with a lot of variety of data. So type of range of data, maybe the data is in form of picture, okay, raw, JPEG, or in term of music, MP3, or maybe in term of video, okay, MP4. Okay, if the data is came from manufacturing, maybe they got digital data, analog data, boolean, number, string, and so on lah. Okay, so there are a lot of data. Okay, then veracity is the data can be trustworthiness. This means kita boleh percaya ke tak data tu. Is the data came from respectable source? Okay, because nowadays there's a lot of fake data or fake data, fake news. Okay, so you need to be careful. Sometimes if you what we call this fake data masuk you punya system, that sometimes that is a malware. You need to be careful lah. Okay, then the last one is velocity. This means the speed of your data. Okay, how fast is your data? Okay, so the speed of data nanti from here we can decide lah sama ada kita nak guna cloud computing or edge computing. Okay, this one is you can go through later lah in our classes. Okay. Okay, the next pillar is the cloud computing. Okay, usually they divide to 3 sections like this: software as a service, platform as a service, and infrastructure as a service. Okay, software as a service, right now there's a lot of software you can use online. For example, I can give is online PDF converter software. So if you want to convert your words to PDF, you can upload it into some website, then it will convert it automatically for you to PDF. Okay, that's an example of software as a service lah. Okay, platform as a service is you utilize their platform to do something lah. For example, maybe you can watching video using Netflix. Okay, you can listen to music from Spotify. Okay, that one is platform as a service. Okay, and infrastructure as a service is maybe this one we can call it as a like our cloud server lah. So for example, we have cloud storage like Google Drive, OneDrive, and so on. So we can save our data into their cloud server. So we don't need any infrastructure lah, like we don't need our hard disk, we don't need our laptop here to store anything. So right now we can store everything inside the cloud. Okay. Then this is the cybersecurity. Cybersecurity is the one of important part in Industry 4.0 because everything is done online, everything is connected online. So there's a lot of threat from hackers. Okay, so they do some phishing, so they can collect your important details, so they can hack to your account. This one you need to very be careful. So the latest famous punya threat is ransomware lah. So if they can masuk into your system, okay, in your PC or so on, they can lock it. So if you want to use your PC back or you want to use your system back, you need to pay some amount to them lah before they release your system again. Okay, this one you need to be careful lah. Okay, cyber security. Okay, the next pillar is advanced robotic. Okay, so usually right now in our industry we use industrial robot. Okay, same like this industrial robot. So we can do spot weld. We can use this one lah to do anything. Okay, but if you can see, usually our industrial robot is run in compound area. So no human nearby the robot lah. Okay. Okay, so there's a lot of waste space. Okay, so right now in Industry 4.0 they came out with this collaborative robot, or the short form is cobot. Okay, we call it as a cobot. So this robot can work with human. Okay, so if it can send human nearby, so it will stop work for a while. Okay, they will stop doing their task for a while until the human pass through the dangerous area. So the robot will resume their work again. Okay, so this kind of robot is very useful because right now human and robot can work together. That's why we call it collaborative robot. Okay, you can visit HRDC if you want to see this kind of robot lah. We got maybe 2 or 3 at upstairs lah. Okay, you can visit and you can ask for our technical specialist to demo this kind of robot to you lah later. Okay, this is more advanced because this is the 2 robot we combine together. But the below one is AGV, or we call it automated or autonomous guided vehicle, and the upper one is the this one lah, robot. So we merge these 2 robot together. So basically this more or less is replace human in industry lah, because this robot can go anywhere. Okay, go anywhere he want. Okay, then the upper one they can do anything he want. So when they merge together, I can say more or less this robot can replace human lah. Okay. Okay, then we talk about system integration. Okay, this is one of the pillar in Industry 4.0. Okay, in current technology, okay, this is the automation pyramid. Okay, so that means our machine or our sensor, everything. So when we want to connect to internet, they will go one layer to one layer. That means, for example, sensor connect to PLC system. So PLC system connect to SCADA system. SCADA system go to MES system. Then lastly go to ERP. Okay, this is the automation pyramid right now. Okay, but in Industry 4.0, everything is interconnected between each other lah. So sensor can communicate directly to ERP, sensor can communicate directly to MES, so sensor can communicate directly to SCADA, even sensor can talk to sensor. Okay, Even sensor can talk to a sensor, sensor can talk to actuator. Everything is interconnected, so we cannot use this automation pyramid anymore lah. So that's mean by doing system integration, our output will be fast enough, right? So we bypass a lot of things here. So this one layer, maybe this one is around 10 seconds, this one is 15 minutes, this one is maybe one day, this is maybe 1 week. If you want to push data from here until ERP, so they're taking a lot of time. But right now, we can have a real-time visualization, or we can get real-time data from sensor, okay? Because the sensor can connect directly to internet. So we can see what is the sensor do right now. So we don't need to go through PLC, SCADA and anything lah. Okay, this is the system integration. Okay, then this is the simulation. Also the one of the pillar in Industry 4.0. So simulation we also can call it as a digital twin lah. So digital twin is digital representation of a physical object or system. Okay, the technology behind digital twin has expanded to include large items such as building, factory, and even city. And some have said people and process can have digital twin, expanding the concept even further. Okay. Okay, usually digital twin is like we have one real machine, but at the same time we have the virtual machine, which is looks similar like the real machine lah. So that's why we call digital twins. They're exactly similar lah. Okay, dan nanti I show you some of example. Okay. Okay, this is some example in industry. So we got one turbine here, and at the same time we got all the data from the turbine, and we can create one digital twin in the digital world lah. So when the turbine is turned on, so we can see the digital twin also can be turned on at the same speed, same power and same output and same movement lah. I can say like that. Okay, this is the concept of digital twin. Okay, even human also can have their own digital twin lah. Kalau if you playing game, this is from Microsoft Kinect Sport. Okay, we can plug in into our Xbox. Okay, when you move, the character inside the game also will move together. Okay, this is some sort of digital twin in gaming area. Okay, so by using digital twin, actually, the good thing of this digital twin, actually, you can test your new program or your new device. Okay, you can test it first before you run it in real world lah. Okay, you can run the turbine. You already got all the data, the spec, the parameter, everything, and you create one digital twin in digital world. So you can run it first before you run it in real world. So you can test if I run like this, what happened? If I run like this, okay, what will happen? Okay, so there's a lot of benefit using digital twin. Okay, this is virtual reality. So actually, virtual and AR, virtual reality or augmented reality, is part of one pillar also. Okay, virtual reality, you can see actually you are in totally different world from our world lah. Okay, you are inside the virtual world. Okay, usually you will use this kind of spec lah. So I'm not sure this one what. This is a HTC Sense or not sure what is this. So when you wear this, actually you are inside the virtual world. Okay, this is the virtual reality. You can move, you can do anything inside there, but it will not what we call it will not dia tak kacau kita punya sistem dekat luar lah. Okay, this is virtual reality. And this is the augmented reality. Okay, actually augmented reality is a real world, but you on top of the real world you put some layer on top of that lah. On top of the real world tadi you tambah satu lagi layer. Okay, you can put anything on that. Okay, for example, this is inside the logistic area. So when you use your phone, use your phone, you can see, okay, they can the data here we show you. Okay, this product still have 5 items remaining, so you can go there. This one that jarak dia 12 meter and others lah. Okay, this is example from IKEA. Okay, so as I can say, now 4.0 is not only in manufacturing area, it also can be anywhere. For example, IKEA use this for your home life. Let's say you want to decide what you want to buy. You already buy a new house, for example, then you want to buy some furniture lah. So you can use their apps. Actually, you can use their app. Then you can see what happen if I put this chair over there. Lawa ke tak kan? What happen if I put cupboard over there? You see the color matching, everything lah. So for this is the IKEA punya apps lah. Okay. Okay. Then I got some example. This is from Ducati. I'm not sure the video can be played through Microsoft Teams or not, but I will try. But I guess it will slow lah. Okay, I tutup dia punya sound. Okay, so in this video, operator need to assemble Ducati engine lah. Okay, okay. So through AR, so ada some instruction dekat sini. So tighten at 15 Newton meter. So dia ada tunjuk kat sini lah. So everything got sensor. For example, this tool got sensor, so connect directly to cloud and to this monitor. Okay, this monitoring system. So take engine cover and put over there. So everything is guided by the system lah. So this is error-proof production. So if there are some error, so the machine will detect lah. The system will detect if there are some error. Okay. Okay, so kita ambil skru ni. Then put it here. Okay. So take the tool. So tighten at 8 Newton meter. So dia ambil tool, then tighten the screw at 8 Newton meter. So this is AR for industry 4.0 lah. So this already ada lah dekat manufacturing. Some area already use this kind of technology lah. Okay. Okay. Macam mana nak keluar? Nak next ya. Next. Okay. Then we talk about additive manufacturing. Okay. Actually, in our technology right now, we got 3 type of manufacturing lah. So we got additive, subtractive, and formative. Okay. Usually, right now we use subtractive lah. For example, if you want to produce or manufacture this mouse, for example, you can see my mouse. Okay. Mouse. So actually, you will have some block of plastic, or for example, this is metal. For example, you get one block of metal, then you will remove the part that you don't want. Okay, you don't want this one, you remove this part, remove. Then you got this ni lah. This tak nampak pula dekat video ni. Okay, this mouse. Okay, now you remove everything, then you got this design. Okay, that one we call it as subtractive manufacturing. Okay, because we remove everything from the block lah. Apa-apa yang kita tak nak, we remove. Okay, tapi yang tu, okay, subtractive manufacturing, there's a lot of waste. Okay, because we remove everything yang kita tak nak kan, and that one become waste. Okay, so right now they introduce this additive manufacturing. Actually, additive manufacturing, nama lain dia is 3D printing lah. Okay, so 3D printing. Previously they use only for some material lah, usually plastic lah. I'm not sure what kind of plastic lah, tapi plastic lah. So they print from one layer to one layer daripada tak ada until siap satu design lah. Okay, so tak ada wastage langsung dekat sini. Kalau ada sikit-sikit dekat bahagian tapak, ada sikit. Okay, okay, this is the 3D printing punya teknologi lah. So right now 3D printing not only for plastic, but right now 3D printing also for metal. Okay, there already some machine, for example, for aeroplane, they use 3D printed machine to print their part lah, metal part. Okay, so in aircraft, they use this kind of technology. So right now, which is the most controversial, not controversial lah. So the latest technology in 3D printing is they can print food. Okay, they can print food. So right now right now, the technology can print meat right now. Okay, in Malaysia now they will consider if this meat can be eaten or not. So is it safe for human or not? So right now they still lah. So I'm not sure UPM or UTM they study about this right now. 3D printed meat. In some country they already use this kind of meat in their food lah. Okay, this is additive manufacturing. Okay, now we come up to digital manufacturing area. So where is digital manufacturing? So I can say digital manufacturing is involved these three pillars lah: simulation, AR, and also additive manufacturing. Okay, all right. So basically digital manufacturing is the application of computer system to manufacturing service, supply chain, product, and process. So that means we use the computer or software in computer to produce our service, our product, and our process. So we can control everything using computer right now. Okay. So this is some data that we need for digital manufacturing lah. So for example, we need to have machine specification, machine configuration, the process data, product certification. Okay, but not only this, but this is some of the data that you need lah for digital manufacturing. Okay, for example, if you have machine specification, then you can draw your machine inside the digital world. So right now, you can have the digital twin of your machine by using this machine specification. Then when you have the machine configuration, you have the machine configuration data, you can configure your digital machine same like the configuration in your real machine. Okay, so right now your machine can move similar or similar like your real machine. Okay, when you have this data. So the process data, how the machine will work, okay, everything. So we put that, okay, and the product specification. Why we need product specification? Okay, this is the 3D printed area lah. So you can print the product. Okay, you don't need another machine around. You can print your product from the 3D printer itself lah. Okay, that's why we need the data, this data. So if you have this data, you can do this. If you have the machine specification data, you can do something like this. Okay, there's a lot of possibility in digital manufacturing lah. Okay. So this is the advantages of digital manufacturing. So as you can see, digital manufacturing can increase efficiency accomplished by a joined-up manufacturing process which eliminate error due to loss or misinterpreted data, which is common for paper-based process. Okay, usually right now in industry they use a lot of paper-based process. That means if you want to take data, okay, operator or technician will go to the machine, so they see the machine, so they see the what we call control panel or the HMI at the machine, then they collect the data by writing it on the paper. Okay, that's what we call paper-based process. Okay. But I give you some example. This is happen in some industry. I got this from my previous student. So they said every morning, for example, every morning technician must collect data of the machine. So every morning when they come to work, first of thing they must go to the machine and collect the data and write it on the paper. Okay, that is their first job. Okay, but sometimes, okay, the technician got something to do. For example, maybe they sakit perut, they want to go to the toilet. Okay, maybe sometimes they have important meeting they need to attend first before they can go to the machine to collect the data. Okay, so later on when they come back, when the technician come back to the machine, so they will collect the data. The data is not accurate lah. So usually the data they take in the morning, but kadang-kadang they take the data on the evening. So the data actually is not accurate. Okay, the data is not the one that the engineer want. Okay, so that's kind of that kind of mistake that we don't want in this area lah. Though that's why this is when you use this industry 4.0 technology or digital manufacturing, so the machine data we can collect it directly to the cloud without without human go, without kita tak perlukan manusia lagi lah untuk go to the machine to collect the data lah. So the data can be automatically collect and store somewhere in our cloud service tadi. Okay, so the data is taken care automatically lah. Okay, this is advantages of digital manufacturing. Okay, so by using digital manufacturing also, you can quicker turn around across all level of the value chain. Okay, for example, you can use machine data and product data. Okay, you can reduce cost of the maintenance lah. For example, before you run your actual process, you can test it or you can simulate it first in your digital world, and you can from there you can you can supervise and you can improvise your process, your machine. Okay, you can upgrade everything semua. Then after that, baru you run it in the real machine lah. So you can reduce a lot of cost and you can reduce the maintenance cost lah. So sebab kalau if you test it first on the real machine and you run and the machine is broken or maybe damaged and everything, so it will increase the maintenance cost lah. So digital manufacturing will reduce this cost lah. Okay. Okay, so from the data, machine data, process data, you also can get the real-time manufacturing visibility lah. So for example, right now, you can sit anywhere, maybe in the office, maybe at the house. Right now, we're working from house. We're working from home right now. So you can still monitor your manufacturing line. Okay, real-time manufacturing visibility. This is what industry want right now. Okay, so the boss can monitor their manufacturing line anytime he want or she want lah. So okay, this is the advantages of digital manufacturing lah. Okay, and it's better if the machine can provide insight data where is the error source. So for example, if suddenly the machine is error, so at the same time, okay, the machine will send info to the technician or engineer or their anyone can send the info to the respective person. What is the error source? Maybe the sensor one, for example, okay, sensor one. So the technician can directly go to the machine and just repair the sensor one. Instead of they go to the machine, okay, the machine error. So dah lah machine error tu, dia lambat dapat tahu machine tu. So kat situ dah ada wasted of time kan. Okay. So when they come to machine, so they need to troubleshoot pula. Dia nak cari pula mana error ni. So that one is also consume some time lah. Okay. So we need to program our machine as little as much. So whenever there are errors, so the machine will send what is the error. For example, right now we can say, for example, the photocopy machine. I'm not sure lah about your house, but in HRDC we have the photocopy machine. So whenever the machine is what we call rosak ataupun ada error, so the machine will show what is the error. So it not only show what is the error, so the machine can give some guideline how to solve the error. For example, open the first door, then tarik laci ni. Then you can see over there, there's some paper sangkut dekat dalam. So keluarkan paper tu. So the photocopy also have this kind of technology lah. So this kind of technology, okay. So engineer one, we did something similar like that photocopy. Okay, all right. Then this is the advantages, the next advantages of the digital manufacturing. So the designer also can test the process before investing time. Okay, this is the similar like what I said before lah. So reduce cost, everything. Okay. All right. So this is some example of digital manufacturing. So you can do virtual communication, virtual commissioning. Okay, you can test it first before you run. So this is virtual check, virtual consistency check. Okay, for example, you can check. Okay, right now, how is the performance of your factory right now? How is the data semua okay ke tak? So semua ada kat sini. So this is digital manufacturing. You also can conduct virtual training using the digital manufacturing. Okay. Okay, so Right now, I'm going to demo to you these two software. One is Factory IO, the another one is Virtual Component. Okay. For example, right now, your boss want you to design an automated machine to sort these two size of box. One is we call it small box, one is the large box. Okay. So macam mana? How you want to design? So then you cakap dekat boss tu, okay, I want to put conveyor, okay, I want to put pusher, or you want to put some sensor lah semua kan. So actually it's hard to explain to your boss lah if you just cakap ataupun you draw some on the paper semua kan. Susah. Why not? You use this kind of software to show to your boss how your system will look like. Okay, for example, this one. Okay, this two system is for sorting machine. Okay, this is the first version. This is the second version. I think this one is the improvised version lah. Okay, this is done using the software Factory IO. Okay, later on I will demo to you how to use this. If you one of my student, I think if you ECPSC student or master student, you already learn how to use this. But if you from another courses, maybe you didn't see this software before lah. Okay, I will demo to you later. Okay, then the next one is virtual component. Okay, this one is higher level compared to Factory IO because this one you not only simulate the machine, but you also can simulate the human, how you want the human behave. Okay, kat sini pun you boleh. So for example, the first scenario is how the original factory layout. Okay, station 1, station 2, station 3, station 4. Okay, when I run, you can see the factory is almost like okay, huru-hara lah. So this is the improvised layout. Okay, you can see, so this is session 1, session 2, session 3, session 4. Okay, so this software can do this kind of thing lah. You can simulate human, you can simulate conveyor, you can simulate robot, everything using these two software. Okay, I want to open this software. Okay, first I want to demo to you about Factory IO software. Okay, first. Okay, Factory IO is a simulator to simulate your machine punya process lah, machine process flow. Okay, first you need to open your program. So I use Siemens PLC, so I program it using Siemens TIA portal. So I just open. So this software is quite heavy resources. So I'm not sure dia akan sangkut ke tak dalam Microsoft Team ni. But I try. We try first. Okay. This is the PLC programming. Okay. So if you gone through the ECPLC program, this is what you will learn. Okay, you will learn how to program your machine lah. Okay, basically this is the program. Okay, actually this is using the German standard. Okay, so we learned this in Germany in 2013 in Icon Institute lah. So this is the format. So they're using IEC standard. So don't worry if you go through HRDC punya module, you will learn about this IEC standard lah. IEC is the stand for International Standard in Engineering. Okay, I run the simulation. So this is the PLC simulation software. Okay, I download it to this software. So I don't need my physical device lah. So this is some kind of my virtual device, virtual PLC. Okay, I run it. Okay, then I tekan ni run. So my programming is run right now. Okay, now I open the Factory IO punya software. So this is Factory IO. Okay, this is Factory IO software. So as you can see, there's a lot of scenario you can use in the software lah. This is the pre-configured, and also you can configure by yourself lah. If you want another machine, you can configure by yourself. So you see, I have a lot of machine here. Okay, actually it's good practice as a student. This is good. It's good practice to have this software lah because you can learn to program a lot of scenario in industry. So if you want to learn analog, you can configure. For example, this is analog. Okay, you can learn how to program the analog machine. Okay, sorting machine and others lah, digital, so on. Conveyor, motor, semua ada dalam ni. So if you want to learn, you can go to this software lah. Okay, where is our my demo? Okay, this is the demo digital manufacturing. Okay, so this is to sort the two box yang tadi tu lah box kecil dengan box besar tu. So file driver, so senang je, you just tekan connect. Tunggu sampai dia sambung kat sini, warna hijau. Okay, kalau warna hijau ni maksudnya dia dah connected, then you just tekan simulate. Okay, so kita kat sini bertugas sebagai orang lah. So kita boleh jalan, okay, kita boleh jalan tengok mesin kita. Okay, so saya tekan start button. Oh, sekejap, saya tutup balik. Sebab kat sini dia ada auto manual. Okay, saya nak run mesin saya dalam bentuk auto lah, keadaan auto. Okay, dan baru saya tekan start. Okay, saya dah linkkan kedua-dua mesin ni dengan mesin ni. So dia akan bergerak pada masa yang sama lah. Okay, saya tukar ini. Okay, nampak. So kalau yang sistem pertama, yang kecil dia akan hantar ke kiri, yang besar dia akan hantar ke kanan. So yang besar they go to the right section and the small box will go to the left section lah. Okay, this one. Okay, you can see the small box will go to this line. Okay, then the bigger one will go to this line lah. So by using this software, you can test which system is more faster. So you can improvise from the cycle time. So as you can see, kat sini kita dah ada banyak kotak, kat sini baru sikit kotak. Okay, kalau kita tengok tadi kan, sebab ada apa? Masa yang ni lagi lambat sistem ni. Sistem ni taking a lot of time compared to this one lah. So of course, if you ask your boss, mesti boss nak sistem yang ini. Okay, that's I say that what we can use this software lah. Factory.io, macam mana kita nak tunjuk dekat kita punya boss sistem macam mana yang kita nak. Okay, selain daripada tu, you also can simulate what happen if a lot of thing lah cerita. For example, what happen if operator terlanggar sensor ni. Okay, dia terlanggar, this is happen in industry. Okay, masa I dekat industri dulu pun sama, ada operator yang terlanggar dan I troubleshoot, rupanya sensor dia sengit. Okay, for example, I run balik. As you can see, so I tekan stop balik, I run again from start. Okay, naik masuk balik auto, tengok apa jadi? Kotak besar kan? So dia tak akan masuk ke sini. Sebab apa? Dia tak boleh detect, tapi dia akan masuk ke tempat yang salah. Okay, ini so besar ke kecil dia akan masuk ke this second station. Okay, so you can see lah what happen. What happen if this accident happen? What happen if operator langgar sensor ni? What happen if you use the wrong sensor? What happen if kalau sensor ni rosak dan sebagainya lah. Okay, this is the Factory.io software lah. You can do a lot of things. So kamu tengok kat tepi ni, kamu boleh ambil macam-macam lagi. Kalau kamu nak buat robot, you boleh ambil robot. Okay, kalau kamu nak try apa, nak try ni, boleh try ni. Tapi kena program lah, program menggunakan software Siemens.ia portal tadi. Alright, so this is Factory.io software. Okay, I tutup dulu. I have to close it first because this is heavy resources. I afraid this will affect my laptop performance lah. Okay, I tutup dulu. Okay, next I will demo to you this what we call visual component punya software. Okay, but I will show you some video only lah. I tak buka software dia. Ya, macam mana nak pergi ke sana? Okay. Okay, this is the simulator that I did lah for lean manufacturing punya. This is I try to simulate the digital manufacturing class. So this is student will learn how to improvise the factory layout. Okay, you can see the first station tengah buat kerja, so second station buat kerja, orang yang ketiga dengan empat nak buat apa-apa kan. So the layout is not good lah actually. Okay, the layout is not good. So they're taking a lot of time to assemble this kind of thing. So nampak, orang ni pergi sana, dia pergi sini. So dia berterabur. Okay. So student will use this visual component software to improvise their layout in industry. So for example, this is station 1. Okay, you see, station 1 dia jalan, dia bekerja. So bila station lagi dekat, so masa lebih jimat. So operator pun tak penat sebab step dia lebih sikit. So orang ni pula akan buat. Okay. So bila kita dah run semua, you can see actually this is the balance. So, actually semua orang akan buat kerja dalam waktu yang sama. So bila ni transfer, so ini pula transfer, ini pula transfer. So dia tak terlalu banyak membazir masa dekat sini. Okay. So this is the visual component software. You not only can simulate human, you can also simulate ni lah machine. This one is better because you can simulate robot arm, you can simulate CNC machine, you can simulate conveyor and everything. And the best thing about visual component software is if you have all the data, actually you can draw your own machine inside here. Okay. For example, you have a machine in your industry, so you can draw your own CAD here. And you can simulate it lah. You can plug into the software and you can simulate it. And the advanced part is, which is I'm not yet done, is this machine, okay, this visual component software can simulate the machine into our VR spec. Okay, right. Okay, I guess that's all for my demo today. Anything if you want to ask, you can ask. I can answer you right now lah. Okay, thank you everyone. Bye.
Cik Zamri.
Ya. Yeah.
Nak tanya yang last tu tak faham sangat.
Yang mana? Visual component
dia boleh simulate dekat VR spec maksudnya?
Oh, if you okay, macam ni Sekejap, I buka dekat Google lah sekarang. Visual component. Okay, this is visual component punya ni, learning material. Okay, kalau kamu tengok kat sini, when you design your machine, okay, when you draw everything, this is the software punya ni, software environment dia, visual component software. Bila you dah draw machine everything, okay, you can use the software to kita plug in this ni dalam kita punya VR. So kita boleh nampak benda ni VR. Kita boleh berada di dalam software ni. Kita boleh jalan-jalan sama macam Factory IO tadi. Kita boleh jalan, tengok mesin, tengok conveyor kita. Okay. Cuma yang ni kita pakai spec tu. So dia lagi kata kalau belajar tu dia nampak macam betul-betul real lah. Kita berada di dalam mesin tu.
Oh, okay, faham.
Okay. Okay, this is some question from this one. Shafiq Nasir, so Zamri, is it possible to collect data like downtime or best cycle time using the Factory IO simulation? Okay, actually Factory IO cannot collect the data lah. Okay, the Factory IO cannot collect this downtime and best cycle time using this software lah. But you can use visual component software to take this data. Okay, downtime. Okay, even in visual component, you can also take the human punya step count. Okay, for example, they go from one station to one station, how many step they will use semua boleh guna gitu. Visual component. But Factory IO cannot. Okay, Shafiq Nasir.
So, is there anything else that you want to add on, Zamri, before we move on to the next agenda?
Okay, I think that's all for me lah. Okay, right.
All right, then thank you very much, Zamri, for your wonderful presentation and demo. On behalf of SHRDC, I would like to thank everyone for attending our TC session.